For question 12, for given one of these questions, they're also known as optimization problems, but it uses differentiation to work out the best possible solution for a given problem. So we get given a triangular prism, so that's a triangular cross-section all the way through, with a total surface area of 3,600 centimeters squared. We get given units for each of these things, x, and we get given a length of prism, y. What we're trying to do here is work out the best possible, the maximum possible volume to have for our prism. So, show that the volume of the prism, V, is given by that. So it says volume, so immediately we're going to look at this shape and try and work out the volume. So volume for a prism is cross-sectional area multiplied by our length. So this is 1/2 15x 20x times y. Because this is a triangle, a half base times height, times by the depth. So this gives us, if I half the 20, I get 10, I get 150 x squared y. So this is V for volume. If we look now at their version of the volume formula, their version of the volume formula doesn't have any y's in it. What we're going to have to do is use our surface area fact to get something to do with y. So our surface area at the moment you're possibly thinking, why would I think to do that? We don't have anything else to look at. We've got to this version of V, it's got y in it. Their version of V doesn't have y in it, and the only other thing we're told about is surface area. So our surface area is, well, we've got two triangles, one on each end. So it's 1/2 times 2 times 15x height 20x base. So we've got 1/2 of, and there's two of them, so these two bits cancel out. We've also got this face here at the back, so this one here, which is 15x times y. We've got this bottom base here, which is 20x times y. We've also got this face here, and we're given this dimension here, it's 25x plus 25x times y. So we're given all of these things, let's collect them all up. So we have 300x squared from here, from 15 times 20, plus 25 times plus 20 plus 15xy. So this gives us 40, this gives us 60xy. And we know that this has to be equal to 3600, because we were given that as a fact in the question. So we've made a surface area equation, and we've paired all of these things up in order to get to our final equation. I can actually do some simplifying here because everything divides by 60. So we get 5x squared plus xy equals 60, which is just a nice simplified version of this. We've divided everything. Divide 60. Okay, so now we need to go back and have a look at what we're trying to do. We're trying to get a volume equation that doesn't have y in it. So what I'm going to do is make this xy is 60 minus 5x squared, and y equals 60 minus 5x squared all over x. By dividing by the x, y equals 60 over x minus 5x. So this is an expression for y which we can use with our volume equation. So we've got volume V is 150x squared, 60 over x minus 5x. If we expand this, we're going to get the result that we get given here, we're going to get v equals 9000 x, because we've got this times this, which gives us 9000, and we've got x squared over x, which gives us x, and we've got x squared times x, so we're going to get minus 750 x cubed, which gives us that. In the past, they've always given this first step. So if you weren't able to get to all the way to there, and you were only able to get part way through, you'll get a big chunk of this 4 marks, but you can still carry on with the rest of the question. So if you weren't sure about the formula for the volume of a prism, you're going to lose a few marks, but you'll still be able to finish the question. We're going to use this now in part B to find the value of x for which v is stationary. So we're after turning points. So we need dv by dx. We're not going to use dy by dx because this is a v instead. So this is 9000, because the x disappears when we differentiate. We need to do 750 times 3, which is 2250 x squared. So we've got this. At our stationary point, we know that dv by dx equals 0, implying x squared equals, well, if we make this equal to 0, we have 9000 over 2250. So we make this equal to 0, we take it over, we divide by that. So we're going to get x equals plus or minus, I'm going to do this on my calculator, 9000 divided by 2250 gives us 4. That's quite handy. And if we square root 4, we get plus or minus 2. If we go back to here, it does specify the value of x. So we can't have this plus or minus. So we need to look back at the problem. And actually x here is lengths. We can't have negative lengths of an object, that wouldn't make sense. So x equals 2. And if we want, it's in centimeters. So we know that our critical value, the one that gives us our turning point, our stationary point, is x equals 2. For the next bit of the question, show that the value of x found in part B gives a maximum. We need to find our second derivative. So dv d2v by dx squared equals. So we've got our original dy by dx here, which is 9000 minus this. This 9000 here is going to disappear when we differentiate this. We're going to get 2 times this. So we're going to get 2250 times 2. We're going to get minus 4500x. So this is our second derivative. We've just taken our first derivative here, that differentiates to 0. This multiplied by 2, which I did on the calculator, reduce the power by 1. Remember to keep this minus sign. For x equals 2, d2v by dx squared gives us minus 9000, which implies that we have a maximum. If you have a negative second derivative, that means the gradient is trying to go down even though it's flat, which means you'll be going like that and you'll end up with a maximum. If you have a positive one, it means the gradient is trying to go up even though it turns, so you end up with a minimum. So that was C. And for D, we're asked to determine the value of y when v is at its maximum. So we're going to go all the way back to here, 60 over x minus 5x. This was our original definition for y, and we know that when x equals 2. So all we're going to do is put 2 into here. So we get y is 60 over 2 minus 5 lots of 2, which is 30 minus 10, which is 20. So we get our final answer for this. Really important in here to state that this is a maximum, not just leave it straight at that. And here we're just after the value of y by subbing in and getting to the optimal value for y. So if you were to make this and you had this much sheet metal, because this is surface area, if you were to set x equal to 2 and y equal to 20 centimeters, that would give you the biggest possible volume for whatever you wanted to keep inside your box.